Visualizing high-throughput Illumina for color sequencing by synthesis. All living things use the same chemical for the storage of genetic information, DNA. Long molecular chains of DNA carry the genetic information from generation to generation of all living things. DNA sequencing is the process of determining the detailed order of the 4 types of chemical subunits, called bases, in these long chains of DNA. The 4 types of bases are represented by the symbols A, C, G, and T. They're chemically bonded together in long chains from thousands to hundreds of millions of bases long. In the 1980s, researchers developed technologies that turn the sequence of chemical bases in DNA into a sequence of colors. In the mid-2000s, digital cameras made it possible to read out the sequence of millions of DNA molecules simultaneously. These new sequencing technologies use sequencing by synthesis. Millions of fragments of input DNA molecules direct the synthesis of new DNA molecules, one base at a time. The newly created DNA is engineered to indicate which of the 4 bases it has by lighting up with one of 4 colors. This is a micrograph made by an Illumina HiSeq machine. The left of the field shows a view of a part of the cell called a tile. The 9 panels to the right show enlargements of the corners of the tile 50 micrometers on a side. The micrograph shows a field of randomly scattered points of light, each of which is one of 4 colors. Each colored dot is a cluster of identical DNA molecules that is being copied one base at a time. After taking a picture of the colored spots, the Illumina machine removes the dyes and adds one more colored base to the growing chain.